One of the standout features introduced in Autodesk Robot 2023 is the load takedown analysis, a tool designed specifically to trace vertical gravity loads through a building structure, from slabs all the way down to the foundations. Yet, despite being available for a few versions now, many users are still unsure about its purpose, how it differs from traditional analysis methods, and when to actually use it. So what exactly is load takedown analysis? And more importantly, how can it support the design and validation of our structural model? To begin with, it's worth noting that this type of analysis is completely optional. You don't need to have started your model using a specific load takedown template. As you may already know, you can switch between different structural templates in Robot at any time, depending on your analysis needs. So what is load takedown analysis? In simple terms, load takedown analysis is a way for us to see how the weight of a building, things like floors, furniture, people, and even the structure itself, gets passed down from the top, through the columns and walls, all the way to the foundations. It's like tracing the flow of weight through the building, step by step, to make sure every column is carrying what it's supposed to, and nothing more. This gives us a much clearer picture of how gravity loads are distributed, especially early in the design process. For example, here we have a concrete building model that's already been designed and fully analyzed. And as you can see, we can easily bring up the internal force diagrams, in this case, the axial forces in each column, to understand how the structure responds under different loads. However, at a glance, we cannot easily observe how gravity loads are actually transferred to each column, or whether there might be a design oversight that, while not critical, could still affect the overall performance of the structure. Or that in some cases, even introduce issues further down the line. Again, this is the kind of issue we want to catch early in the design stage, not once the model is already undergoing detailed analysis. In this case, for example, we've already assigned multiple load cases and combinations to the model, and so far we haven't identified any issues that might compromise the integrity of the structure, or any of the concrete members for that matter. However, we've yet to assign seismic, wind, or other dynamic loads. In fact, we could say this is still an ongoing project, and more structural elements may be added as the design progresses. This means that, while the model appears sound at this stage, we're not entirely free from the risk of unexpected behavior as the structure continues to develop. So it's in cases like this where load takedown analysis can really help. This type of simplified analysis allows us to quickly spot any lack of continuity in the way gravity loads are being transferred through the structure. So let's now take a look at this model using the load takedown building design template and see what insights we can uncover. To start, while working within this template, we can open the Load Takedown Diagrams dialog. Among other options, this dialog allows us to quickly visualize the load paths affecting the columns, along with the resulting reactions for each active load case. What we're seeing here, for example, are the reaction values corresponding to the currently active load case, and these, at least in terms of individual gravity loads, align closely with the axial forces calculated in the columns. Now, before going any further, let's recall that unlike full structural analysis, which include the results for the axial forces, load takedown analysis does not consider additional load effects, such as lateral forces, moments, or torsional effects. As a result, these values may diverge when analyzing more complex load cases or full load combinations that include dynamic or lateral effects. Still, the purpose of this analysis, and it bears repeating, is to quickly identify design issues related to load path continuity or potential problems caused by gravity loads acting on columns and their supports. For example, if we now run the analysis on this model using the load takedown building design template, we'll get some interesting results that we wouldn't obtain otherwise. As we can see, even though no major structural issues have been flagged, the load takedown analysis has already identified potential problems in our model. These issues, while not critical, could impact the structural behavior later in the design process. Specifically, the analysis highlights these three members, as one of the columns has been removed at the lower level. Due to this change, the system recognizes that the behavior of the connected elements has shifted, from being simply supported to behaving like cantilevers. As a result of this condition, there's now a lack of equilibrium under basic load cases. Again, this doesn't immediately imply a structural failure or overstressed concrete sections. It simply indicates that gravity load transfer is no longer continuous throughout the model. Of course, in this simplified example, that may be fairly obvious, but in a more complex project, missing something like this could become a serious design oversight. Finally, we can also bring up the load takedown tables, and through which, among other things, we can quickly obtain the tributary area tables, helping us understand how much area of the slabs contributes to each column. In conclusion, load takedown analysis provides a fast, simplified way to trace gravity loads through your structure. Unlike full structural analysis, it focuses only on vertical loads, making it easier to catch modeling issues, verify load paths, and size columns or foundations early in the design process. It's a practical tool for improving accuracy and efficiency from the start. If you found this information helpful, don't forget to subscribe and follow us for more content on civil engineering, structural analysis workflows, and practical software tips.